In this section, we will build a language recognizer. Starting from Wikipedia pages, we will build a language classifier that we will test with other Wikipedia pages and some free text. Let's start with data preparation and text processing. Before going into the real subject of our section, which is to make a language recognizer, we need to quickly mention some typical text processing steps that we will implement with other famous Python packages. While going through our script, we will gradually understand the use of this package. TensorFlow, no need to describe. NumPy allows array operations. Pandas, we will use it to read and manipulate files and columns content. And LTK provides a list of English stop words. To do this notebook, we will use New York Times user comments from Kaggle datasets. When we will create the language classifier, we will use other data. But now, let's rely on an English natural language source. So now, we read the data. Let's have a quick look at the data, trying to find what is the column that we need. Looks like comment body is the right candidate. Now, we first put everything to lowercase and then replace undesired characters. Let's check how the text looks like now. Well, everything is lowercase and no ugly characters. Now, we remove stop words and then fill empty cells with fill NA word. This is how our clean text looks like. We can see that everything is lowercase and the stop words are missing. For example, this project makes me happy becomes project makes happy. Finally, TensorFlow. Now that we used other Python packages to clean and prepare our text, let's start using TensorFlow to build a dataset that we will be using as an input for our models. The general text processing steps in TensorFlow are the following. Tokenize our text to turn it into a sequence of integers. Then path sequences, which means transform our sequences of codes in order to have same dimension. We will see an example that explains this clearly. For example, we have two sentences. S1, TensorFlow is great. And S2, Packt Publishing is great. Tokenizer would transform every unique word like this. TensorFlow equal 1, is equal 2, great equal 3, Packt equal 4, publishing equal 5. Then our sentences would be S1 equals 1, 2, 3, and S2 that equals 4, 5, 2, 3. Path sequences would add a 0 into S1 that will become 0, 1, 2, 3. And in this way, the cardinality of S1 would be the same as S2. Now, we can build a matrix because the cardinality is the same. And this matrix can be used as an input for our model. The first row of the matrix is 0, 1, 2, 3, and the second is 4, 5, 2, 3. Let's go back to code. We first assign our current data frame to another to keep track of our work. Then we read the first sentence and count the words that result to be 21. Then we set the maximum number of words to 5,000 and the maximum sequence length to 100. Now we perform the tokenizer step and then fit it to clean text. This is how we create sequences. Let's take a look at what we have now. We see that the type is list and that the number of words is decreased to 16. We had 21, now we have 16. And this is how our sentence looks like now. Exactly a sequence of integers. One step is missing, the padding step. Let's do it. Let's print it. Well, this is how our sentence looks like after the padd step. We don't have any more 16 words, but 100, equivalent to max len. Let's remind the input text, and let's see, after translating it into a data frame, well, This is our matrix.
In the next video, we will look at building and training the neural network.